Basically, data structure stack today we discuss. Data structure is a structure that we can organize the data in a systematic manner. So stack is a sequential data structure. It is an application of array where we can organize the data sequentially, but we have to follow a certain sequence where the data inserted from one end and the removed from the same end. That's why the stack is called as last in first out data structure. Also we can call it as LIFO data structure. So stack is a last in first out data structure. The information is organized sequentially. We have to write a certain method to organize the data. Suppose this is array representation, and these are the indices. Suppose we consider that the array A of 5, these are the sequential index where we can store an element. If it is an array, we can insert and delete the element from any index. But if it is a stack, we can remove the element that will be inserted last, will be removed first. That's why it's a last in first out data structure. So sequentially we have to maintain one of the variable called as top of the stack. So always we have to maintain one of the variable top, which will increment when we insert the element and which will decrement when we remove the element from the stack. So initially we have to consider a struct as a stack and put some information variable inside a stack, integer, top, and the array where we have to store the information. The size is nothing but a constant variable. We can assign the number of locations for a stack. Means we can add n number of elements in an array. So size is space where we can put that number of elements. So this is a declaration of a stack where we can add an element. So this is the structure of stack where we can insert one by one element. Now we will physically check how the content are being traversed, or how the elements are traversed inside a stack. So initially, this is representation of stack. Having top is pointing to the initial index that we call as a -1. So initially stack is pointing to the -1. That is the basic initialization of top. Then as soon as we insert the element inside a stack, then the top is get increment. So when I add the first element inside a stack, then top will increment, the element will get inserted. Suppose 9 will insert it and top will pointing to the next one. So this is an operation where we can insert element inside a stack. So top will be incremented when we insert the first element in a stack. Then again, if I add one more element in a stack, then top will increment by 1. Likewise, the top will increment every time when we insert the element. Again, suppose if I add an element inside a stack, then again stack will get increment. So sequentially we can add an element in a stack, that top will increment 1 by 1. So now this top is pointing to the topmost location of the stack. So if I remove the element from the stack, I cannot remove any other element than the top element. Because the data structure stack is an organization of data where last in first out information is organized. So last in first out information is only organized in a stack. That's why we can remove only the topmost element from the stack. So if I remove the element from the stack, so this is a remove operation of a stack. Remove operation of a stack where we can remove the element. So when I remove any element from the stack, or we can say topmost element, not any element, we can remove only the topmost element. So top will increment and the top will now pointing to the previous index, that is 10 element. So the previous index is pointing by top by removing one of the element. Similarly, when I remove the next element, again top will decrement by 1 and top will look like this. So this is a representation of stack in general way. Now we are going to discuss how this stack are going to be implemented as a data structure. We know that various programming languages are there to implement this data structure. We can select any programming language. Suppose if I select any particular language, then we have to identify certain control structure and data structure for the implementation of the stack. So basically stack as an ADT, abstract data type. We have to design stack as an abstract data type. For that, there are certain operation of a stack that we have to consider. So what sort of operation we have to discuss under the stack? First of all, we have to initialize the stack. So initialization of stack is important. So first I initialize the stack. Then I have to perform certain operation on a stack, like I have to insert the data inside a stack. So that operation we call as a push operation. Then if I want to remove the data from the stack, then I have to use pop operation. So push is an operation, pop is an operation inside the stack. These two are the operations. For that operations we have to check two conditions. That condition are stack is empty and stack full. So these two conditions we have to check while inserting and removing the data from the stack. So stack empty and stack full condition. So it is very easy to understand that when I implement the operation of a stack, push operation, that time I have to check one of the condition either empty or full. That we are going to discuss. And when we perform same pop operation, that time we have to check one of the condition. Now when we have to check the stack empty full condition, suppose if I want to push any type of information inside a stack, that time we have to check whether the stack is full or not. Means what? When I insert any type of information, we have to check the size of stack is full. If it is full, we cannot add an element. But if it is not full, we can insert an element. Means when a push operation is performed, we have to use or check stack full condition. If stack is full, we cannot push the data. But if stack is not full, we can push the data. Similarly, pop operation. When I pop any element from the stack, means when I remove any element from the stack, that time we have to check one of the condition, that is pop. So push and pop are being utilized in a stack to check whether the content of stack are empty or full. Now how we have to implement this concept in C or C++, that we are going to write.